You know, for all of human history, we've looked up at the moon. It's right there, our constant companion in the night sky. But what if I told you that familiar face has been hiding a secret? A wild history of fire and chaos that we're only just starting to figure out. Let's dig in and piece together the clues. So, the whole mystery kicks off with something that sounds super simple. The face of the moon that we always see looks completely different from the side it hides from us. And I'm not talking about a few extra craters here and there. We're talking about a massive geological puzzle that has kept scientists scratching their heads for decades. Okay, so just take a look at this. The contrast it's just wild. On the left, you've got the near side, the one we all know. It's got all those big, dark splotches. Back in the day, people thought they were seas, so they called them Maria. That's Latin for seas. They're actually huge ancient plains of hardened lava. But then you look at the far side, and it's like a totally different world. It is rugged, it's mountainous, and it's just been absolutely pummeled by impacts. Its crust is way thicker, and you hardly see any of those dark lava plains. So, why? And that's the question, isn't it? This is where we stop just looking at the moon and start playing detective. And our best clues? They're not coming from a telescope. Nope, they're coming from actual rocks, brought all the way back here to Earth. To crack this case, we have to look at the evidence. And in this lunar mystery, the evidence isn't a fingerprint, it's actual physical pieces of the moon, brought home by some legendary missions, both old and new. This timeline really puts it all into perspective. Back in the 70s, you had the Apollo and Soviet lunar missions giving us our first taste of moon rocks. But then, for more than 40 years, crickets, nothing. But now, just look at this. It's all happening. In 2020, China's Chang'e 5 mission brings back the first fresh samples in a generation. Then in 2024, they do it again, but this time from the far side, a total first. And with NASA's Artemis missions gearing up to land at the South Pole, well, we are officially in a brand new golden age of moon science. And this is where the plot twist hits. See, the original story from the Apollo rocks pointed to one single massive event, a giant cosmic hailstorm of asteroids that just walloped the solar system about 3.9 billion years ago. After that, we thought the moon just cooled off, became a dead rock. But these new samples from Chang'e, they just flipped the entire script. The bombardment wasn't one big event, it was drawn out. And, get this, they found proof of volcanic activity happening just 120 million years ago. In geological terms, that was like last week. So here's the bottom line. We might have been completely wrong about the moon. Finding out that it was geologically active so recently, for a little world that should have run out of heat billions of years ago, it forces us to rethink everything, not just about our moon, but about how planets are born, how they live, and how they die. I love this quote from NASA's Samuel Lawrence because it just perfectly sums up the shock here. He's basically saying, everything I was taught is being turned on its head. The textbooks are literally being rewritten as we speak. It's just such a great reminder that in science, nothing is ever set in stone. Now, just so we're all on the same page about why this is such a mind-blowing discovery, let's talk volcanism. It's just hot, melted rock, magma, erupting on the surface. Simple enough. But for a small body like the moon, which should have lost all its internal heat eons ago, finding recent volcanism is like walking into a supposedly abandoned cabin in the woods and finding a warm fire still crackling in the hearth. It means there's still something going on inside. This is the basic idea, right? You've got a hot pocket of magma deep underground. Pressure builds, and that molten rock forces its way up to the surface. And boom, you have an eruption. Finding evidence that this very process was happening on the moon so recently is what has scientists absolutely buzzing. It tells us the moon's engine didn't shut down when we thought it did. So how exactly do scientists get these ancient, quiet rocks to spill their secrets? Well, it's an amazing process that basically turns a geologist into a world-class detective, unlocking a story that's been trapped in stone for billions of years. It's this super meticulous, careful process. First, obviously, you get your hands on the rock. Then, back in a super clean lab, they cut off a slice so incredibly thin, it's practically transparent. Finally, they pop that little sliver of the moon under a powerful microscope, and that is where the real magic happens. And just look at this. On the left, you've got a plain old gray rock. But on the right, that's what a geologist sees. It's this beautiful, dazzling landscape of crystals, all locked together. The size, the shape, the chemicals in those crystals, they tell the rock's entire life story, how it was born, how fast it cooled, everything it's been through. It's literally a history book written in minerals. So, this isn't just about rewriting history books. Figuring out the moon's geology is actually super important for our future because we're getting ready to go back. And this time, we're not just planting a flag and leaving. We're planning to stay. The truth is, our map of the moon is still full of blank spots. We've got about 385 kilograms of moon rocks, which sounds like a lot. But they all come from just a few spots, mostly on the near side, near the equator. That's like trying to understand all of planet Earth by only studying rocks from, say, Florida. You're missing most of the story. That's why missions like Artemis are so important. They're finally going to completely new places. And what we could find there could change everything. We're talking about prospecting for the future. We think there might be huge amounts of water ice at the poles. If you have water, you have drinking water, you have breathable air, and you can make rocket fuel. Then there's stuff like helium-3, which could be a source of clean fusion energy back here on Earth, not to mention rare minerals we need for all our electronics. The moon isn't just a pretty light in the sky anymore. It's becoming a serious strategic resource. This quote from geologist Clive Neal just says it all, doesn't it? Every time we send a new mission or look at a new rock, we realize just how much we still don't know. It feels like every answer we find just leads to a dozen new questions. It's what makes this all so exciting. So, I'll leave you with this final thought to chew on. We've just seen how a few pounds of new rock completely turned our understanding of our closest neighbor upside down. So just imagine, what's going to happen when we finally bring back the first samples from a whole other planet? What kind of secrets are waiting for us in the red rocks of Mars?